In today's video, I'm going to show you how to make a Contra Rotating propeller simulation. So first we will have to make our Contra Rotating propeller set. First we have to start MATLAB. We will again make the propellers in OpenProp. So first I'm going to make the first propeller. The forward propeller. This propeller I will make the same as I used in my thesis. So it will have a rotation speed of 700 RPM. So I will use the same propeller as in my thesis. I have already saved it, this propeller. So it's with 3 blades instead of 2, and these are the parameters to run it, and these are all the design performance parameters. So let's take this propeller, I place it here. I will call this one front. And now I will make the aft propeller. But for the aft propeller we have to make the propeller go counterclockwise, so I have to mirror the Y direction in the output file. So I will run it again. This is the same output file I used last time. It's still the export SolidWorks version 18. These are the file. So it's just all. This is the only important parameters. We run again. It's the same propeller, but just now mirrored in the Y direction. So let's run it. Okay, no different parameters, just the same propeller. Normally you can simulate the first propeller and use the inflow profile. So you can set the propeller like a Contra Rotating propeller. You can simulate the inflow of the water from the fluid from the first propeller. It will be different than the second propeller. Most of the time I use the ship speed, just increase it, but it won't change the result. It's hard, so I will not do it this time. This is just a tutorial, so for how to make a CFD simulation of the for a Contra Rotating propeller. So will I use the testing maps? No, I will not use them. Yeah, I will use them. These are maps I used to make a macro of the propeller. What's a macro? It's so you can design the propellers automatically, so you don't have to make it by hand. I can show you on the end of the video why I did that. But first let's do it manually. So how will I do it? First of all, I will make a new CAD model and import 3D curves. Testing. So this is the front propeller. Spline again. See, just sections, loft, none, and let's use an airfoil. Okay. My set, create sketch. So all the same parameters as last time. Now the radius is a bit bigger than last time, so I will have to adapt the rotate region a little bit, but I will do that after making the propeller. The propeller sets, excuse me. Body features, pattern. And it were 3 blades. Okay. None and okay. Extrude, not merge, no. Will I merge? No, yeah, I will merge, it's easier to merge. It's not in the way. Into asymmetric. Okay, so it's one body, I will call it prop 1. Update, close 3D cut. So the first model, this prop is not necessary anymore, but I can let it be there. Just it won't interfere with the simulation. But I will have to make the rotate region bigger. It will now be 4.5. Okay, and then the refine region. What's wrong with this one? I don't know. Doesn't matter. Eat it. That's just 1.6. Normally it's 1 to 5. I can calculate it. 1.4 times. Yeah. A little bit more precise, but not that important. Okay, new. Let's give it some names. This is the stress. This is Contra Rotating propeller 1. No. I'll name it 2. This is, yeah, no problem. This is for later when I will use the macros, because they are set by this. But first, let's make the aft propeller. Aft spline. Okay. Airfoil. No. Different religions can. Okay. Yep. And no, let's first. So, this is the simulation, also none. And in the last step, I will merge it again. extrude. Normally it won't interfere with the rotate region because it's in another you say it's model 3D model group, so it won't similarly interfere, but I will look into it if it will interfere. I will know the errors normally. So these can go away, and these can also, well, it can stay, it won't interfere. Very fine. Okay. New geometry part. Very fine. Okay. So now you can see the benefit of using this instead of just selecting them. Name contains prop 1, prop 1. The names haven't changed, so I can just execute and don't have to select them all. So I will do the here, it won't matter that much. But now I will just cannibalize my simulation from last time and use it the same for a Contra Rotating propeller. Wait, I have to make some changes. I forgot, excuse me. I will of course have to translate it in the X direction negatively. Of course, how can I forget? Update, close 3D cat, and of course I also have to make another rotate region. So duplicate, yep, we call it rotate 2, and duplicated body I will transform it. Transform translates also in the same minus X direction. Oh no, of course I can't duplicate it. I can't do that because it's different. It has different dimensions as the first one. But I can use a sketch. Yeah, I can use a sketch and extrude it. Let's not take a risk, just let's make a new sketch. It's a bit risky. Normally that won't be a problem, but I will not take the risk. It's not that much of work. And two-way symmetric. Okay, and just none. Okay, and then this body will be called rotate 2. Okay, and transform translates. Okay, let's hide the domain so we can see. So they are linked up perfectly. That was also the meaning. And you can see them both in here. So this is where the first propeller will be, and this is where the second propeller will be. I'll just check it one time to be sure, but he did 2.5. Okay, that's perfectly. Okay, update close 3D cat. So I will have to make also a new geometry part of the, excuse me, rotate 2. The other one will just update, and then all of them can update, all of them. The prop 2 is this one, I think. Just to be sure. I forgot I've done it or not done it. So prop 2, okay. This can be copy and paste, and then copy of subtract. I will call it rotate 2. Rotate sub 2. Rotate sub 1, and this is fluid sub. So I know with what I've been busy. So this is prop 2. Okay, this is rotate 2, and there is no tip in the second rotate region. So exactly, and this contains, yeah, it's good normally, contains rotate 2, yes, okay, execute, and execute. Fluid sub, so rotate. I will also cannibalize this one. Excuse me, the fluid sub isn't complete. Rotate 2 also in there, of course. Execute. And the rotate mesh. I'm going to copy it, paste it, and it's no copy of subtract. I will call this rotate sub 2, and this also will be set to a new assign parts to region. Oh, I will make it myself easier. I already have that region. I will just use a copy and a paste, and I will call row 2. That's good. The input parts will be rotate sub 2. Okay, so that's all set up. This is active, this is not active. Okay, it's good. The physics will also have to change. The initial condition is for this race is only 4 meters a second. It's my endurance, it's for the endurance race, this propeller. So the speed is lower than for the sprint race. And here also it won't change, but in the fluid region, the physics values, the inlet speed will also change to -4. Okay, so this is all changed. I've done the parts, and so now I will be making from this thing. I will rotate to these will be split. Can I split it here? No, I can split it here, this part, but I can split it here. Normally, no, if I haven't executed the mesh, of course. So rotate to boundaries. The main rotate. No, I will have to make a new. I will call it. Well, I will just do this. Yep. Copy. Oh, it won't work. Yeah, just a new favor. Rotate to, I will call it 2. Okay. And there is rotate 2. Okay. And it also has an interference with this. Rotates 1 is 2, and I will call it. We rename them just not. I know what and prop 2 and rotate 2. Okay, and then here to rotate 2. Also an interference, yeah, an interference of course, and then there also has to be another interference, but that's for soon. So these are all set correctly. Physics vertical values, okay. And normally they are. So now the tools. I will create a new motion, copy, paste, of course, and I will change the rotation rate to -700, and this one is 700. Okay, that's also set up correctly. So now the mesh. Okay. For the first simulation I will use a mesh results of the first time, it's not that bad. Okay, and then I can change the wall settings. Okay, that's good. Just to make some new reports. I will do that soon. First, let's run the mesh for the first time. Yes. And I will come back when it's done calculating the mesh. So you can see for the first time the mesh is not good. It's too big, but I forgot I've done some wrong things. Also, I want to hide the mesh from our stress simulation because it just irritates me. So I go to scenes, and no, I'm not going to scenes. I'm going to where is the ports? No, don't even know. Just make it so. Okay, it's display injection regions, just not the stress region. No stress, so I can see it a little bit better. And you see there are prism layers here, and that's not just not okay. So I have to change it a little bit. But let's start with this mesh. First of all, I'm going to make also an interference between this surface and this surface, because first of all, otherwise the fluid will go here and then go around, so it will not be the real situation, so it's not good. And then the second reason is the mesh between those two propellers has to be a lot more refined than in the front of the propeller or the sides. The sides can also be refined, but this region in particular has to be really fine. So I will also make that change to it. That will also be used for the duct simulation, but that's later on. So first, how can I do that? I go to rotate, surfaces, and split by patch. Front, not needed. This, yes, this has to be refined. So I will call this back. Okay, great. And maybe also rename this one just side and front, so I can do what I want with all of them. Okay. So front. Okay. And the next one, surfaces, will also do split by patch. I will combine. Wait. What's here going on? So these and what's that? This is. Oh no, that's not good, eh? What's this? Ah, yeah. So this is the side. This is the front, I guess. It's not clear, eh? What's that? It's really not clear. Wait. So, just split by patch and choose this thing to create it and call it front and see what will happen. And this, okay, it's the front, okay, it's good. Wow, that was really strange, but okay. So that's okay, that's done. Of course, that's not okay. I will have to re-execute all these things. Execute. Okay. Then in the geometry scene, no, I don't have to copy there. In the regions, I will change a lot. So the boundaries. This is good. This is not good. New, and this can stay, but it will be only the front and the side, and then this is the back. Okay, now we can call it back. Okay, then right here, boundaries, prop. Okay, that's not good. We will make a new one. Okay, that's well good. Yeah, okay, that's okay. And then here's the front. Okay, front. And here, this is the back. They are one and the same, so it will create an interference. Okay, so that's set up all okay. Oh no, it's not. Here, physical value, motion, rotation, that's normal. That's okay. Normal. And here it's copy of rotation. It's in the other direction, of course. I think I also set it up correctly. So let's go in here. This I won't change for today. These are all normally set up alright from the last simulation. But here, this is prop, so I will call name contains prop1. Why do I do it like that? Not just select it? For the same reason I did it right here. So if I change the propeller for another propeller or something, I won't have to do it again. So it will be set automatically, and when I say create mesh, it's alright and I don't have to look to it. This also I will do it like this. Name contains. It was already set up automatically, but just to be safe, rotate one. They are all good. No. 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 I will select them all. This front. Okay, and then or name. Or name. Name contains rotate dot side. Dot the capital. No. Rotate one, of course. Okay, that's set up correctly. And this is prop and tip, of course. Prop plus or wait, isn't the prop and the tip is the same? Like, yeah, the prop and the tip is the same. Oh no, tip. Just to be safe, I think it's the same, but just to be safe. Okay. Okay. And then I will make a new surface control, and I will call it back. And this will be the back. Just select it. Just select it. Target surface size custom, and with the front, you can see with the front it was 0.3, and here I will say it's 0.1. Make it a little bit finer than in the front. So let's go to the back. Custom controls. The same. You don't say name contains prop 2. Okay. And then here also an extra surface control. But first I'm going to do name contains rotate to dot default, and then here it's name contains rotate to dot front. Okay, and now I call this okay. Custom, just to make it a little finer in front of the propeller, because there are a lot of changes in the water right there. Speed changes. Rotate is also custom, and the prop is normally selected perfectly. Yeah, it's normally alright already. Okay, then I can wait a little. I'll use this and check if the prism layers are disabled. Yeah. And here, are they here disabled? Controls, prism layers. No, they are not disabled. They have to be disabled. And then here it's the same, I guess. In the rotate region they are already disabled. Normally I don't have to target surface size 0.3 because of the volumetric control. I didn't also do it last time, but just to show you I did it now. And then here also disable. That's the main purpose of this surface control, to disable the prism layers because they are not needed here. And I will execute the mesh right now and see what's the results. So I will come back to you when the mesh is ready. So the mesh generating took some time right now, around 5 to 10 minutes it took for me. But let's look at the results. Oh, excuse me, that's the wrong view. I have to set. Okay, you can see the mesh right here. Also this, you can see. I think I made a mistake in the fluid mesh. It's the volumetric control. It's not looking that bad actually. Customs, okay. Well, it's good. Could be a little bit finer, but yeah, it's just a fluid mesh, not that important. So let's make it a little bit more better for the eye by including also the second propeller. Okay, let's make it visible. So now you can see the propellers, and even you can play a little bit with the opacity right here, and then it will be like this. You can see through it. You can make some nice pictures if you're into that. So we can see here is a boundary, the boundary I used. So here on this is the mesh much finer than on the other sides. You can see these cells are much bigger than these cells. The same is right here, also much larger than in these. So you can see the custom sizing of the mesh in this. Custom controls here, the custom size of the mesh. As set here, it would be much smaller than there. Let's use this picture for my master thesis. Okay, let's go further. So here you can see the mesh. So with the mesh complete, I can go to post-processing. So it's all set up correctly from the last time I remember. Yeah, they are not set off and these are off. Okay, that's good. And let's go to reports, make a new report of system user. New report, metrics. It's a flow energy, also a trust, and a new report. Torque. It's of course in the x-axis, and here the same. It's in the x-axis. Okay. Regions. Now rotate to. It's of course the prop. It is still correctly selected. Yes, selected correctly. And then here it's of course also parts, regions, rotate, prop 2. Okay, these are all set up correctly. Oh, prop 2. Oh. Don't make mistakes. Prop 2. Okay. So for the plots, I'm just gonna call it moment 1, 2, 1 and 2, and I'm just going to include them. Data series, stress monitors. Can I just scene plots? Just first let's clear the solution. Just make it myself easy. Delete, just select them both and create a new plot, single plot. Oh, what's happened? And did I select something wrong? Plot from the board, single plot. Yeah. These trusts 1 and 2, and then torque 1 and 2. Okay, these are all set up correctly. Yeah, that's from the last time. I think everything is set up to start the simulation. Let's see if I made a mistake. There's always a possibility, of course. It's such a big setup. So I have a better vision. It's saved. When did I save it? Oh, why? Ah, okay. I can save it. Let's save it. Where is my output screen? I wonder why it's always disappearing. Probably I did something wrong. Let's run. So this simulation will be much more intensive than the last simulations I did, of course. Why is my residuals right here? I want my residuals here. No, here. What's happening here? Okay, residuals. Okay, and what's here all happening? First iteration. Let's just see if with the first iteration I just start in the right amount of thrust and torque in the right axis. Same here, so there are no strange things happening. You can see directly with the first two or 3 minutes which direction the simulation is going. What you have to look at, first of all, the results. The residuals, well, it's important they don't spike to, let's say, e1 e to the minus 10 or something like that. Just so it can spike. This is okay, but spiking, that's not good. And then another thing you have to look to is first the thrust and 1 and 2 will be around the same values, and it will go. Thrust 1 is rising. Yeah, that's possible. That's entirely possible. Not normal, but not that alarming. Just look at it for some time. Normally they will both go to what's that? OpenProp sets. They will be around 100 newtons and 6.65 newton meters in torque. So let's see where they are going to. Yeah, no, they are going to the right direction. Let's come back when the results are in. What did I do? Of course, still have to run. And I will pause the recording for when the results are ready. So while it's calculating the thrust and torque from our from this simulation, I will show you the thrust and torque from our already completed simulation. It's the same than this one, but it's already completed a while back. So this is the thrust and this is the torque you normally would come out. You can see here the torque is it's just calculating, but the same as this one. So it will be around 7 newton meters. Both around 7 newton meters, and the thrust will be, let's say, 105 around that value. Not that precise. Normally you will have to do export, but that's already shown in video number 2. So then I made this Excel document also. Let's fill in 105, and then 7 for both. And you see you will get around this value. The first one will be let's say a little bit higher, but it will go down. So what's happening here physically? So in the first propeller will be blocked by the second propeller. So that's why there is a dip in the, and then while the first propeller is blocked by the second propeller will get a boost from the first propeller. You see this boost in torque thrust from the from the first propeller, but then the dip again when the boost is over, and then it will go further, and then it will repeat itself. So this is a contra rotating simulation. Yeah, this is a more complete simulation. We have more parameters. I also have more scenes in this one. Maybe I can show them. These are the Yeah, it's loading. I will pause the simulation so it will be loading a little bit faster. Maybe I can show you my computer stats. Well, my computer's working. So this is the computer I'm doing the simulation on. It's AMD Ryzen 366 core processor, and it has 16 GB of RAM. So the processor and then the RAM. You can see that while A+ values are high, between 5 and 30, that's the region you don't want to be in. This is around the propeller tip. I can show you a full picture. So here they're high. The rest of the propeller is low. It's below 1, so that's good. But here the A+ value is too high. You can decrease this A+ value by increasing the number of prism layers. But yeah, maybe I can show you another scene on this mesh quality scene. Maybe it's also interesting. So this is a mesh quality scene. What can you see right here? Here are the problems in the mesh are visualized here. So here is a big chunk, it's not good, but here are also some chunks that are not good. And here are some others. Maybe I can show you too. These are the chevron faults. You can see. And here the quality, cell quality. It's not a big impact on this. The phase validity. So where I don't see them directly on this mesh, but yeah, this is the propeller. So if I hide them, yeah, propeller is away. And the skewness angle, these are these faults. You can see here the skewness angle, and then the volume change. Here are some volume changes that are not okay. You can decrease these faults with increasing the mesh resolution and the meshing. Maybe this is the meshing from this. Here the quality is only for the first mesh, but I can show the second mesh also. So if I include it, yeah, how can I do that? Parts. Oh no, I'm not in the mesh quality scene plots. Where are them? I think they are volumes. Yeah, they are volumes, so I have to change them in here in the drive part. So you can see here I have to select all the regions. Phase validity. So you can see now also from the second propeller what are the faults. Skewness angle and the volume changes. Yeah, so here are some volume changes. And then this is the skewness angle, so yeah, maybe the mesh has to be refined a little bit. Here in the back you can see it's not good with the second propeller. But overall I would say the mesh is not that bad, but yeah, it could be better. But then my computer will calculate too much. It's a fine balance. But yeah, this is the quality scene. Are there some other interesting scenes? Yeah, here's velocity, so you can see the propellers are working together to get to a higher velocity right here. You can see the trail of the propeller. The vorticity is that an... It's more a beautiful scene, yeah, it's more a beautiful scene. So you can see the slipstream of both propellers right here. I can use this one for... Let's use this one for our thumbnail. So let's make the surface, the parts. Let's select both props. Why aren't they? Prop. So okay. Yeah. Velocity scene. Yeah, you can see the velocity right here. Maybe something else. The tangential velocity is quite interesting actually. Where is the tangential velocity? Yeah, it's not that important. And then I don't know what else. It's velocity tangential. Tangential. Here is a tangential velocity. Yeah, you can see the propellers, the impact of both propellers in the slipstream. So I think I got all. Yeah, I got all the scenes, got the mesh scenes, both. Yeah. Okay. So thank you for listening. Let's end the video here.